Hello. Today we're going to talk about the absolute basics of chemistry. Basically, we're going to look at the atom and the subatomic particles and how those lead to chemical bonds. And I just want to say at the outset, I'm sorry if I'm going to be sounding a little funny today. I am in the midst of being sick and my throat is struggling, but I'm going to do my best here. So let's dive into it. So here are all the key terms for this particular lesson that we're going to talk about. There's more in this overall unit of chemistry, but for this particular set of slides, here's what you need to know. So as we've been talking about, life is highly organized. And ultimately, the organization of the cell itself is important to life as well. And that organization is chemical. And chemical organization ultimately boils down to physics. So this is another reason why, even though you're an engineer, it's important to know all levels of science, because if you don't understand the underlying physics, you won't appreciate the chemistry. If you don't appreciate the chemistry, you can't understand the biology. So we learned that the cell is the basic unit of living things. So you are alive if you are a cell, but there's smaller things that are not alive that make up the cell. And those molecules and atoms and subatomic particles are the topic of today's lesson. So the basic unit of matter, and basically the thing that makes everything up in the universe, is the atom. And so it's crucial that we understand what it is and how it works. So this atom, the building block of matter, is divided into two main parts. You have the nucleus, and then you have what we call the electron cloud. So the nucleus, you can see it here and right here. It's blown up into this image right there. This is the dense central portion of the atom, the nucleus, and it contains pretty much all of the mass. There's mass in the electrons surrounding it, but the vast majority of the mass of an atom is found inside the nucleus. And it's made up of two particles that have mass themselves, and those are protons and neutrons. Neutrons have no chemical charge. They are neutral. That gives them their name. But protons have a positive charge to them. So overall, the charge of the nucleus is positive. So surrounding the nucleus is the electron cloud. This is a region where the small negatively charged molecules called electrons are most likely to be found. So why do I use such language, most likely to be found? Well, if we look at this model of the atom here, this is the Bohr model. It's the original model of the atom when we first started hypothesizing and theorizing about the atom itself and its existence. And the idea was that we had the nucleus with the protons and neutrons, and each electron followed a very strict path around the nucleus, and there was different path levels that you could follow. And while this isn't completely false, it's a lot more probabilistic than that. So it's more saying that there are regions or kind of areas that occur in levels around the nucleus where the electrons are likely to be found. And each level contains a certain maximum number of electrons that it can hold. But not just that, there's a probability that the electrons are found in these levels. Sometimes they'll be in there, sometimes they might not. Electrons are very interesting things. There's a lot of quantum mechanics that get involved with electrons that we do not need to go into in this level class. But basically what you need to know is that the electrons surround the nucleus, and they surround the nucleus in what we call energy levels. So every level surrounding the nucleus has a different level of energy, and it can hold a certain number of electrons within that energy level. Now, electrons are so important because they are the reason why chemical reactions occur, and we'll get into that more in a second. So overall, atoms will have specific properties based on their numbers of protons, neutrons, and electrons. all of the atoms that have the same number of protons are called elements. So every single element will have the same number of protons. If you have one proton, you are a hydrogen atom. If you have two protons, you're a helium atom, and so on and so forth. So while elements all have the same number of protons, they may have different number of neutrons. And when that happens, when you have more or less neutrons, you call those isotopes. Now, some isotopes are stable and others are unstable. And what we mean by that is over time, that nucleus will decay in such a way that it will release either neutrons or other types of particles, and we call that release radiation. So isotopes can be stable where they're inert and nothing happens to them and they remain the same with the same number of protons and neutrons in that nucleus, or they can be unstable and radioactive where eventually that nucleus will decay and pieces either of the neutrons or other subatomic particles will get released. Then the electrons are responsible for determining the charge of the atom. If the protons determine the identity of the atom, electrons determine the charge. What do we mean by that? Well, in an ideal world and on paper, every single atom will have the same number of protons and electrons. It'll have the same number of positive and negative charges to balance it out and make it neutral. But in reality, rarely ever do we find all the atoms of something in that perfectly neutral state. Electrons like to have full energy levels. So as I said, every single step around the nucleus can hold a certain number of electrons. And atoms like to have their energy levels full. So either they want to collect electrons to fill it up, or they want to lose electrons to empty it and get rid of that energy level entirely. So when an atom loses or gains those electrons, they create something called an ion, or a charged element, basically. When an atom loses its electrons, it'll lose one of those negatively charged particles, or two or three. In that case, it becomes positively charged because now the protons outweigh the number of electrons. We have more positive charges than negative. And we call those ions cations. And then when an atom will gain electrons, so now we're taking these on, we're becoming more negatively charged. So that ion becomes negative and we call it an anion. So because of this desire to fill or empty our energy levels in atoms, the atoms will often barter their electrons to attempt to do this. Either they will exchange them and say, we're going to share these electrons, or they're going to say, I'm giving these up, you can take them. And the other atom says, great, I'll definitely take those because that'll fill me up. So whenever those exchanges of electrons occur, it produces chemical reactions. And usually these are between two or more atoms. It can be the same atom, like the same element, or different elements. It just depends on the situation. So when those atoms share electrons with each other or transfer electrons, they create what's called a bond. Now those two atoms are no longer separate from each other. They're going to be bonded together, and they're going to create a new type of chemical out of this exchange. So if we have hydrogen and oxygen, those are both gases. However, when we exchange electrons between these and you have one oxygen attach itself to two hydrogens, we now have H2O, which is water, which at room temperature is a liquid, no longer a gas. So when these chemical reactions occur, we form entirely new compounds, entirely new creations that have their own properties. Now, I'm going to use these terms, and for the purposes of our class, I use these terms interchangeably. I honestly don't really think about the difference when I'm talking about them, but just know molecules and compounds are technically two different things. A molecule is formed when two or more atoms of the same element are bonded together. So technically, the gases, a lot of the gases in our atmosphere are they have two atoms bonded together. They don't exist just a single oxygen floating around. We call it diatomic. So in the atmosphere, oxygen always bonds to itself. So that's a molecule. The two oxygens together, the two hydrogens bonding together, those are molecules. A compound forms when two or more atoms of different elements bond together. So like water, two hydrogens, one oxygen. Those are different elements bonding together. Methane, one carbon, four hydrogens bonding together. Amino acids, carbohydrates, DNA, these are all compounds that we're going to talk about through the course of this class. So the way that these electrons are either shared or exchanged determines the type of bond and the qualities and characteristics of the connection between those two atoms. So when the atoms share electrons, they form covalent bonds. These are very strong bonds. It's often between nonmetals. So something like lithium or iron, those are metals, whereas oxygen and nitrogen and hydrogen, those are non-metal elements. So usually covalent bonds form between non-metals, and these are very, very common in biological molecules because we have carbon often bonding to oxygen, nitrogen, sulfur, phosphorus, hydrogen, and all of those are what we call organic molecules. And so when we're looking at those are all nonmetals. And the sharing of the electrons between all of them creates those strong, strong covalent bonds. Now, there's a really interesting phenomenon that occurs where electrons don't necessarily get shared equally. If you remember, with these energy levels, sometimes they're really close to being full. Usually we want to fill them with 8 electrons. So if you have 6 electrons, you're going to want to take 2 electrons. If you only have 2 electrons in your energy level, you'd rather give those away. That's much easier than finding 6. And it's much easier to take 2 than to give 6 away. So because of that, elements have this characteristic that we call electronegativity. You don't really need to understand that. I'm not going to test you on it, but if you've heard that term before, that's what I'm discussing here. And because of that, if an atom wants to take electrons, it's going to share those electrons unequally. It's going to hog those electrons a little bit more of the time, and the other atom is going to give up those electrons a little bit more of the time. Technically, they're both using them, and they're both using them in the form of this covalent bond, but one of them is going to hog them and take them a little bit more of the time. So that's polar, that unequal sharing. I apologize, there's a typo here. That should say unequally with an E right there. When they share them equally and both atoms have the same amount of time with the electron, that's called a nonpolar covalent bond. So covalent bonds are sharing electrons. We can share them equally in a nonpolar event, or we can share them unequally and create a polar molecule. So the other way that we can deal with these bonds and move electrons around is by actually losing and gaining electrons. So rather than sharing them, sometimes an atom will literally give up 2 electrons or take an electron, whatever it needs to fill its outer shell. So when this happens, an ion is formed, and an ion is a charged atom. So in the case of this hydrogen right here, it has 1 electron. It's going to want to give that up. So it's going to lose that electron entirely and become a cation. It's going to become positive. Whereas the molecule that it's bonding to needs, excuse me, needs 1 more electron. So as a result, it's going to steal that electron and become more negative. As a result, now that positive ion and the negative ion are going to want to associate together because positive and negative charges attract in the chemical world. So that bond between the positive and the negative ions is called an ionic bond. These usually form between a metal and a nonmetal, and it's created by electrostatic forces. So that is the other type of bond. We're not going to deal with these quite as much. We deal more with the covalently bonded molecule or compounds in this particular class. But just know that the other main type of bond is an ionic bond. There is a third bond called a metallic bond, and it's definitely not something that we're going to deal with in this class, but you might need to know it if you do go into materials engineering or anything like that. So I've kind of mentioned properties and how an element has properties based on how many protons and neutrons it has. It has a charge based on how many electrons it has. But that when it forms a chemical reaction and a chemical bond, the new thing created has its own set of properties. Hydrogen and oxygen are gases, but water is a liquid at room temperature. So we break these down into two different properties. There's physical properties. These are the characteristics that are observed without changing the substance's chemical identity, the color, the melting point, the hardness. But the chemical properties, these are going to be the ways that we describe how a substance reacts to form new substances. They're only observable during or after a chemical change. So these are going to involve a change to the substance's chemical composition. So it's actually changing into some new type of compound or molecule. So a lot of chemical properties are things like flammability or reactivity with water, things like that. And the last thing we're going to talk about is polarity and hydrogen bonds. I'm going to introduce it here and we're going to hit it home in the next video as well because it is quite important. So I mentioned before that we can have polar covalent bonds where the electrons are shared unequally. That unequal sharing of electrons due to electronegativity means that one atom is going to pull those electrons and hold on to them a little bit more often than the other. So the molecule overall is neutral. There's no truly positive or truly negative part to the molecule. It's overall neutral, but there's areas that have partial positive or negative charges. Sometimes this area will be positive, sometimes this area will be positive, and sometimes this one will be negative. So this is going to become really important when we talk about the example that's being shown here, which is water, which is going to be the subject of our next video. So because they have partially negative and partially positive areas and positive and negative charges interact, these polar molecules can form an attractive force to each other. It's not a true bond. We call it a hydrogen bond, but it's more like an attractive force. Almost think of it like two magnets coming together. It is not a magnetic force, but you can almost think of it that way for how it behaves. These two things are interested in each other, they come together, they attach, but they don't share electrons. They don't chemically bond and chemically react, so they stay the same compound with the same properties. It's not like this molecule and this molecule are sharing electrons and becoming a whole new molecule. In this case, if these two molecules did chemically interact and bond, we would form hydrogen peroxide, which is not what we want in this case. The water just wants to form a hydrogen bond to another water. In this case, they're all staying water. They're not becoming something new. So because of that, it is not a true bond. We're not sharing and we're not transferring electrons. And we're going to talk about the implications of this and why it's so important next time. All right, so that is it. Let me know if you have any questions, and I hope you have a great day.